8 plus 4 plus 2 plus 1. In fact, the maximum it can represent is 15. So I want to express 16 words. It must be 40s. Stands for 16. The rest can be pushed according to the rules. Then if 50s represents 32. If 60s represents 64. If it is 70 represents 128. You can do the math after class, according to the method I gave. Okay. Now I'll give you a different way of writing. Correspondence between binary and decimal. We might as well write, assuming that each bit takes a value of 1. We can convert these 1. When the last digit is taken as 1. Here it represents 1. This is the last. Then here are 2. Here are 4. Then go forward to 8. This table is derived from our previous calculation. A value of 1 in the last digit means 1. Corresponding to this bit is 1. If the first bit is 1, it corresponds to this 170. Stands for 128. In fact, everyone will find we spent so long studying these 8 numbers. It's because these 8 numbers are very closely related to IP addresses. Each of our sets of decimal numbers can be represented by 8 binary numbers. In other words, 32 bits in binary equals 4 decimals. There is a conversion relationship. Actually, the IP address should have been 320101. The reason why it can be written as 192.168. Just because of this. Because all 8 binary can be expressed in decimal. Their lengths are exactly equivalent. Then let's study exactly how they are calculated. For example, what we just wrote. 192.168.1.111. So how exactly does it count as binary? Let's calculate together. Calculating this process is actually quite simple. I will simulate a scenario for you. This scene is quite interesting. Suppose I now draw a square. We divide it into 8 equal parts. These 8 equal parts correspond to the previous values. The top is 128. Then down to 64. 32. 16. We are now going to perform a calculation. Suppose compute 192.168.1.111. We're going to take a decimal number like this. Convert it to a 32-bit binary number. We're going to do a transformation. Now we're going to convert it to 0101. You can also calculate it yourself. Can be hit on the screen. First, let's simulate a scenario. We call this kind of algorithm the number crunching method. This is the most basic method. We express each group in 8-bit binary. That is to say, 192 I want to take 8 binary representation. 168 I will also take 8 binary representation. I take 8 binary representations for each group. In the end I followed the order. Arrange it in order to get a result. Then I draw this shape on the left. It is to simulate a scene for you. Like you are now the boss of a company. Let's say you have 4 employees. 192 respectively. 168. 111. Say you want to give them some rewards. That for employees. You have some different handling mechanisms. If you do a good job, you will be rewarded more. For example, the first person does the best. You're going to buy it something for $192. Suppose these scenes on the left are something on the shelf. Cheaper and cheaper from top to bottom. So it's up to you to spend all your money. How much can you buy? Let's first calculate this 192. If I take this to buy 128. Can buy. 192 equals 128 plus 64. From top to bottom. Definitely pick the expensive ones first. When will the money be spent? 192 can definitely cover 128. So here it is set to 1. This bit must have a value of 1. Because 192 can cover 128. Equal to 64. 64 is exactly the price of the second thing. That's the equivalent of being able to afford this. So the value is 1. After buying 64. The following is 0. It's like the two most expensive things you've bought. Then you won't be able to buy them all. So it is equivalent to all take the value of 0. After we calculate such a value, we sort from top to bottom. 2 1 6 0. Then it represents 192. Let's look down at this 168. First of all, 128 can be bought. 168 minus 128 equals 40. That 64 can't be bought. Then the value is 0. 32 is available. Value is 1. 16 can't buy it. Value is 0. 8 is just right to buy. Value is 1. After buying 8. After that, all values are 0. So the binary representation of 168 is 10101000. We won't talk about the third one. This one can only buy the bottom one. Then there are 7 zeros in front. We look at the last one 11. First of all, 128 can't buy it. Value is 0. 111 minus 64 equals 47. Also equivalent to 64 is affordable. Value is 1. 32 can also afford. Value is 1. Then subtract 32 from 47. Equal to 15. 16 can't afford it. Value is 0. The sum of the following is exactly 15. So you can buy it later. All values are 1. So now the binary representation of 111 is 011011111. So now these four sets of numbers. Let's put them in order. We line it up. That's the equivalent of a 32-bit binary number now. Actually, it's not as difficult as you think. When many students first learn base conversion, always find binary and decimal conversions particularly difficult. That's because people are too lazy to do the math. If you think it's a little more difficult, then every time you count, you can list these numbers first. In fact, wait until you basically finish the whole stage. You'll be familiar with it soon. Okay. It's in decimal. Below is the binary. They are converted using such a method. If you think this method I'm talking about not very easy to understand, then you can find another way. I think this should be the easiest way to remember. That is, for now, the overall address expression is like this. So now I want to ask you another question. 32-bit binary. If I want to express it as a decimal IP address. So what is the maximum IP address? How small is the smallest? We can use a binary calculator. This calculator can be turned into a programmer's calculator. Programmer's calculator is binary from bottom to top. Octal, decimal, and hex. For example, in hexadecimal I write an A. Binary it is 1010. Represents a 10. 10 in decimal. In octal, every 8 in 1 is 12. Octal is